In this video, we are going to discuss about definite integral and the value of definite integral as the limit of its sum. Now first, try to understand the meaning of definite integral and the calculation of value of definite integral. Let y equal to fx is a given function and graph of given function is mentioned here, which is continuous from x equal to a to x equal to b. Means we can say it is a continuous function and differentiable in closed interval a to b. X equal to a means from point L to M, or on graph paper we can say from point A to B. Now coordinates of point A. L means distance of point L from origin is A. Therefore y coordinate at this point is FA. In graph, in place of x write down A, you will get the value of y. Therefore coordinates of point A is x comma y. X is A and y FA. Therefore coordinates of point A is A comma FA. Similarly coordinates of point B, x B, and in place of x we write B to y equal to FB. Then coordinates of point B is B comma FB. Are 2 points on the graph. Here objective we want to find the area bounded by the graph of function y equal to fx and x-axis from x equal to a to x equal to b. Means from x equal to a to x equal to b, between graph and x-axis we want to find area. Since a between a and b, it is a curve part, not a straight line. Therefore divide whole length from L to M in n equal parts, having equal width such that LP1 is same as P1 P2 equal to P2 P3. Similarly, last Pn minus 1 M equal to H. Means width of each rectangular part we can say H. Now height of each rectangular part. First rectangle, if you observe, height of first rectangle is FA. Second rectangle height FA plus H. Similarly, height of third rectangle FA plus 2H. And here in this pattern, height of last rectangle is FA plus n minus 1H. Now since we want to find the area of this region, first just calculate the value of LM. Distance between L and M. LM we can write as OM minus OL. Value of OM is B and OL A. B minus A. And since we have divided LM in n equal parts, from L to M we have divided this whole base in n equal parts, and breadth of each part is H. Therefore total LMB can write as NH. Means NH equal to B minus A. Write as equation first, because width of each rectangular part is H, and there are how many rectangles? N. Therefore total length from L to M we can write as NH, and which is equal to B minus A. NH equal to B minus A. If we find area of all rectangle and add them, you will get area, but it is not accurate. To find accurate area, you have to decrease the value of H, and if you decrease the value of H, then area under AQ is same as area of rectangle. Therefore we can say if we decrease the value of H, then number of rectangles will increase. Therefore total area under the curve we can write as width of rectangle is h, height fa, h into fa plus second rectangle again width is h into height is fa plus h because coordinates of point q1 is a plus h comma fa plus h. Similarly next h into fa plus 2h. Similarly write down area of all rectangles. Therefore we can write as if n is very large means n tends to infinite, then h is very small or we can say h tends to 0 or h is approximate equal to 0. Then area bounded by graph x-axis and ordinates are between x equal to a to x equal to b is given by area of ALMB which is equal to h into fa plus h into fa plus h because in each rectangular part width is h and height first rectangle is a, second rectangular height is a plus h. In third rectangle width is breadth h and height fa plus 2h. Similarly last rectangle nth rectangle h into fa plus n minus 1 into h. H common inside the bracket fa plus h plus fa plus 2h up to fa plus n minus 1 into h. If h tends to 0, then area of ALMB we can write as limit h tends to 0 h into fa plus h plus fa to a plus 2h plus fa plus n minus 1h. Right equation second. The expression second is called the definite integral of fx from a to b and is denoted by integration of a to b fx dx which is known as definite integral, where a is known as lower limit and b is upper limit. Therefore, we can write as integration of a to b fx dx equal to limit h tends to 0 h in bracket fa plus h plus fa plus 2h dot dot up to fa plus n minus 1h. That is known as formula to find the area under the curve and x-axis from x equal to a to x equal to b using limit of sums. Here integration from a to b means sum of all small rectangles whose breadth is dx and height fx from x equal to a to x equal to b. That is the meaning of LHS and which is equal to RHS using formula. In solving questions based on definite integral, there are some identity required which you should know. Sum of first n natural number. There is use of this identity. We should know the identity. The sum of first n natural number is n into n plus 1 by 2. Or if I ask is sum of n minus 1 natural number, then in place of n write down n minus 1. n minus 1 into n by 2. Similarly, sum of squares of first n natural number is n into n plus 1 into 2n plus 1 by 6. Or sum of squares of n minus 1 natural number we can write as n minus 1 into n into 2n minus 1 by 6 because in place of n, n minus 1. In place of n minus 1 means n minus 1 plus 1 n written. Here 2n minus 2 plus 1 2n minus 1 upon 6. Or sum of cube of first n natural number n into n plus 1 by 2 whole square. Or sum of cube of n minus 1 natural number we can write as n minus 1 into n by 2 whole square. So whenever required we can use these identities. Or also you should know sum of n terms of a GP. Sum of n terms of GP we can write as Sn equal to a plus ar square up to a r n minus 1. Here a means first term and r is gamma ratio. We can write as a into r power n minus 1 upon r minus 1 if r is greater than 1. And if r is less than 1, then formula we can write as a into 1 minus r power n upon 1 minus r. If we have to find sum of n minus 1 terms of GP, then in place of n, write down as n minus 1. A into r power n minus 1 minus 1 upon r minus 1, or a into 1 minus r power n minus 1 upon 1 minus r. And similarly, sum of n terms of AP equal to n by 2 in bracket 2a plus n minus 1 into d, where a represents first term and d is common difference. Or sum of n minus 1 terms of an AP, we can write as n minus 1 by 2 in bracket 2a plus n minus 2 into d. So these identities are useful in solving questions based on limit of a sum. Now, some questions. Find integration from 1 to 5 2x plus 1 dx as the limit of a sum. First, you compare integration 1 to 5 2x plus 1 dx with integration of a to b fx dx. So we can write as fx equal to 2x plus 1, a equal to 1 and b equal to 5. Therefore, nh equal to b minus a equal to 5 minus 1 equal to 4. Just our result written related to fx, a, b, nh. Now, formula note down for limit of sums. Integration a to b fx dx we can write as limit h tends to 0 h fa plus h plus fa plus 2h up to fa plus n minus 1 into h. Now, integration of 1 to 5 2x plus 1 dx we can write as limit h tends to 0 h, and value of a is 1. In place of a, write down 1. f1 plus f1 plus h plus f1 plus 2h up to f1 plus n minus 1 into h. Then next step, since fx equal to 2x plus 1 and first time I have written f1, it implies in place of x you have to write 1. 2 into 1 plus 1. Limit h tends to 0 h. First term is 2 into 1 plus 1 plus f1 plus h means 2x plus 1. In 2x plus 1 in place of x write down 1 plus h. 2 into 1 plus h plus 1 plus third term 2 into 1 plus 2h plus 1 and last 2 into 1 plus n minus 1h plus 1. If you open the bracket, just observe here, limit h tends to 0 h. 2 into 1 plus 1, it is 3. Here, open the bracket. 2 plus 2h plus 1 means 3 plus 2h. First term is 3, second term 3 plus 2h. Now next 2 plus 4h plus 1, 3 plus 4h. Here 2 plus 2 into n minus 1h plus 2 means 3 plus 2 n minus 1h. So therefore, next step we can write as limit h tends to 0 h, 3 plus 3 plus 2h plus 3 plus 4h up to 3 plus 2 into n minus 1 into h, which is equal to limit h tends to 0 h. There are how many terms? 1, 2, 3 up to n terms. Means addition of 3 n times plus in first term there is no term of h. Here 2h, 4h up to 2 into n minus 1h written here. The collection of first term in every term written. Then second. Now next step, addition of 3 n times. If anyone asks addition of 3 5 times, 3 into 5. Addition of 3 n times means 3 into n, 3n plus. Here 2h common. If 2h common, what remains? In place of 2h, 1 plus 4h means 2h common, 2 remains plus here 2h common, what remains? N minus 1. 2h common, 1 plus 2 plus 3 up to n minus 1 means sum of n minus 1 natural numbers. Already we have discussed the identity sum of n minus 1 natural number, that is n minus 1 into n upon 2. So 2 cancel out. Then next step h into 3n plus h into n minus 1 into n. Now next open the bracket. So h into 3n means 3nh plus h square into n minus 1 into n. H square 1h write down in this bracket, then h minus h and second h with second n in h. Now put the value of nh. Since nh already we have calculated as 4b minus a equal to 4. In place of nh write down 4. 3 into 4 12 plus 4 minus h into 4. Now apply limit. In place of h write down 0 and you will get result as 12 plus 4 minus 0 into 4 equal to 28. In this pattern, if any question is given based on definite integral, we can solve using limit of sums. One more question. Find integration of 2 to 5 e power x dx as the limit of sum. Now, here fx equal to e power x, a equal to 2 and b equal to 5. Easily we can write. And then nh equal to b minus a equal to 5 minus 2 equal to 3. Then note down the formula. Integration of a to b fx dx formula written here. Then next step, apply the formula. Apply the formula means integration of 2 to 5 e power x dx equal to limit h tends to 0 h, and since value of a is 2, in place of a write down 2, f2 plus f2 plus h plus f2 plus 2h plus f2 plus n minus 1 into h. Now next step, since fx equal to e power x, therefore f2 equal to e power 2 plus f2 plus h means e power 2 plus h plus e power 2 plus 2h plus e power 2 plus n minus 1 into h. Since e power 2, next step e power 2 plus h we can write as e power 2 into e power h. Similarly, next step e power 2 plus 2h we can write as e power 2 into e power 2h. Then equal to limit h tends to 0 e square plus e square into e power h plus e square into e power 2h plus dot dot e square e power n minus 1 into h. Here e square common, and if we take e square common, the remaining part we can write as 1 plus e power h plus e power 2h dot dot up to e power n minus 1 into h. And now you can observe in bracket it is in GP such that first term is 1 and comma ratio e power h. Therefore, apply the formula for sum of n terms of GP, a into r power n minus 1 upon r minus 1. Here value of a is 1 first term and comma ratio r equal to second term upon first term equal to e power h. Therefore, limit h tends to 0 h e square inside the bracket 1 is a into r power n minus 1 upon r minus 1. Here value of r is e power h. Then next step, limit h tends to 0 h into e square e power nh minus h, open the bracket, e power nh minus h minus 1 upon e power h minus 1. Now next step, in place of nh we can write as 3. Nh equal to b minus a equal to 3 already given, we have calculated here. Therefore, in place of nh write down as 3. Then in next step, in numerator we can apply limit. The result you will get in next step e square and numerator in place of h if we write 0 e power 3 minus 1. And remaining part we can write as limit h tends to 0, h remains in numerator and denominator e power h minus 1. Then next step we can write e square into e cube minus 1, 1 upon limit h tends to 0 e power h minus 1 upon h. Already you have covered in limits and derivative this identity, and value of limit h tends to 0 e power h minus 1 upon h equal to 1. Therefore, value of this whole denominator is 1, and then you are getting final result as e square into e cube minus 1. Therefore, integration of 2 to 5 e power x dx equal to e square into e cube minus 1. Now next, question number 3, find integration of 2 to 3 x square dx as the limit of a sum. If you compare with the standard form, you can find fx equal to x square, a equal to 2 and b equal to 3. Therefore, nh equal to b minus a equal to 3 minus 2 equal to 1. Since formula you know, apply the formula. Limit integration of 2 to 3 x square dx we can write as limit h tends to 0 h into fa. Here value of a is 2. f2 plus f2 plus h plus f2 plus 2h dot up to f2 plus n minus 1 into h. Limit h tends to 0 h f2 fx equal to x square. It implies f2 equal to 2 square, f2 plus h equal to 2 plus h whole square. Next 2 plus 2h whole square, 2 plus n minus 1 into h whole square. Then next step, limit h tends to 0 h 2 square. Here apply formula a plus b whole square, a square plus b square plus 2ab. 2 square plus h square plus 2ab means 4h. Then third step, 2 square plus b square means 2 square h square plus 2ab. Now next, a square plus b square plus 2ab. In this pattern we can expand it. Now here in every term we can write 2 square, 2 square, 2 square, 2 square. How many times? N times. Then next we can write h square plus 2 square h square dot up to n minus 1 square h square. In this pattern, write separately these three terms. And next step we can write as limit h tends to 0 h 2 square plus 2 square plus 2 square. How many times? N times. Plus second term h square plus 2 square h square dot up to n minus 1 square h square. Then collection of third term from every term, 4h plus 4 into 2h plus dot 4 into n minus 1 h. Here next step, 2 square plus 2 square. How many times? N times. Therefore, its value will be n into 2 square plus h square common inside the bracket 1 square plus 2 square up to n minus 1 square plus 4h common 1 plus 2 plus 3 up to n minus 1. Then in next step, limit h tends to 0 4nh 2 square 4 and multiply by h 4nh plus h into h square h cube and sum of square of first n minus 1 natural numbers we can write as n minus 1 into n into 2n minus 1 by 6 plus multiply by h 4h square into n minus 1 into n by 2. Then next step, 4nh plus h cube written 1h write down with first bracket nh minus h, second h with second term is nh and third h multiply in second bracket 2nh minus h plus 4h square one h write with first bracket nh minus h, and second h with n write down as nh. Now put the value of nh. Value of nh is 1. 4 into 1 equal to 1 plus in place of nh1 1 minus h into 1 into 2 minus h by 6 plus 4 1 minus h into 1 by 2. Now apply the limit. Apply the limit means in place of h write down 0. 4 plus 1 minus 0 into 1 into 2 minus 0 means 2 upon 6 plus 4 into 1 minus 0 into 1 upon 2. 2 2 is 4. 2 equal to 6 plus 1 by 3 equal to 19 by 3. In this pattern, integration of x square dx from 2 to 3 we can write as 19 by 3 means area under the curve from x equal to 2 to x equal to 3 enclosed by x-axis is given as 19 by 3 square units. Now some questions for practice. In question number 1, integrate x dx from 1 to 4 as the limits of a sum. In question number 2, e power 2x dx integrate from a to b by the method limit of a sum. And question number 3, 2 to 3 x square plus x dx as the limit of a sum as limits given 2 to 3. So these 3 questions you have to solve and complete your answer.